In this video, we're going to be looking at how to look at some solutions of some of the equations that we've been graphing. So we're going to look at a couple graphs that we looked at last video in the linear relations video 10. And we'll take a look at how to use it to estimate certain values, to estimate solutions to this. So here's the graph or the equation y equals negative 3/5 x. So recall that we're using the form y equals either y equals mx plus b or y equals b plus mx is what I usually use. And so if we were to match that up, I should have just written this down here in the first place. We see that the b corresponds with 8 and the m corresponds with negative 3/5, which means that our x-intercept, or sorry, y-intercept is 8. So on the y-axis, we'll look up here and we'll plot the point right at 8. And that corresponds to the ordered pair 0, 8, because we've gone 0 units in the x direction and 8 up in the y direction to get to this point, starting from the origin. And then from this point, I'm going to count out the slope. And remember that we're always going to be running, if we know that slope is rise over run. So this is the rise, and this is the run down here. We're always going to run to the right, which means that that negative sign is going to come up and be beside the negative 3, or sorry, beside the 3 to make it negative. And then so the fraction would actually, the equation would end up being y equals 8 plus negative 3/5x. Okay, so then that when we rise, we're actually going to rise down because that's negative. Okay, so starting at 8, we're going to go down 3 units. So we're down 1, 2, 3, down to here, down to 5. And then we're going to run 5 units to the right. So we're going to go 1, 2, 3, 4, 5. Okay, and then from there, now that we have 2 points, and to me they seem relatively well separated, I'm going to now join those points and extend the line to make a nice good long line. Actually, I'll extend it as far as I can here. And then I'm going to go in the opposite direction. Okay. And so there's the line. Now from this, the big thing that we're going to be taking away from this is we can then use the line to estimate different values. Okay. So suppose I wanted to, so we know the y-intercept. What if we wanted to look for the x-intercept? Well, we can just follow along the line. And we can see that the x-intercept is right down here at 13 and 0. Now, these are just estimates because, as you saw, it was a little bit challenging for me to draw the line in both directions quite easily. When you have paper and pencil and using a ruler, there's always that little bit of human error that could come into this. So if you're not super, super precise, then you may get values that aren't quite true. So that's why we're calling these estimates. Okay, we can find the x-intercept by solving this algebraically, and then it's much more accurate. Okay, so then we can look along here and we say, well, what does y equal if, for example, let's say here, if I say, okay, well, x equals 5, what does y equal? Well, then starting from x equals 5, I'm just going to go up to, and I should be using a ruler for this, go up to the line, and then when I hit the line, I'm going to go across to see where what that y value is. And in this case, it actually ends up being 5. Okay, so the solution to this, when x equals 5, y equals 5. What if I said, well, what is the value of, what's the value of x, for example? Let's see if I can get a good point here. Go down another 3. 1, 2, 3. What's the value of x when y equals 2? Okay, so I'm going to start at y equals 2, and I'm going to go across here all the way until it hits the line. And then I go down And actually, as it turns out, now is this supposed to be the actual value? I don't know, because I'm estimating. And as it turns out, this is what I'm estimating is 9.5. Okay, but if we were to follow the slope of the line and we went down from this point, we know this point 5.5 is on the line. Okay, because I counted out the slope. If I go down 3 from this point, so go down at 1, 2, 3, and then go across 5, 1, 2, 3, 4, 5. This is where the line actually should go through. It should go through the point 2, sorry, 10, 2. Okay, x equals 10, y equals 2. So that's where the point should go through, where the line should go through. But because my graph, my sketching was off, it didn't get through that point exactly. Okay, and that of course will then throw off this this x-intercept as well. Okay, so that's the danger of, well, not danger, but that's where the imprecision comes in when graphing by hand. Okay, but this is how we would be estimating values by using a graph. Okay, so this is one of the graphs that we used on the last day. Now I'm going to skip over, and actually here, let me just pause this for just a second. I'm going to go over to, this is the same graph that we just finished graphing. And this is in Desmos, and this is a fantastic piece of software, because if I click on the line here, I see there's the x or the y-intercept of 0, 8. And if I come down to the y or the x-intercept, I see it's not perfectly 13. It's actually 13.3 and 0. Okay. And then the other thing I can do is I can click and I can drag down along the line, and I can see different values that are on the line. So if I go up here to x equals 5 and see if I can hit it right on. Sometimes it's a little tricky to get perfect. So if you can just bear with me for a second. So I almost got it. 5 point, or it should be 5 and 5 as I'm struggling here. But the point there it is, 5 and 5 is the point that's on the line there. And if I drag down a little bit further and go to 10, I see that the ordered pair here is 10 and 2. Can't quite get it. There we go. Okay, there's the next point, point using integer values. And then here's another point, 15 and -1. Okay, so this is a very powerful piece of software that we can use to kind of find points along a line. All right, so let's move on to the next graph that I wanted to look at. And that is here. We're going to move here at -10 and 2/3 x. So this is another graph that we graphed the other day. We know that -10 is the y-intercept, so we're going to plot that right here. And we know that, I hope I said the y-intercept because that's what it is. And that is at the coordinates 0, -10. And then from there, we're going to count out the slope of +2/3. So 2 is the rise and 3 is the run. So from here, I'm going to go up 2. So 1, 2. And then I'm going to run to the right 3. 1, 2, 3. And there is the next point on the line. And I'll rise another 2, and then I'll run another 3 to get to here. And then that's where I will draw the line. And of course, remembering that lines go in the same or in opposite directions forever. And so I'm going to start here. I'm going to go up and extend the line. And I'll do the same thing in this direction down here as well. Okay. And so again, here's the graph. And if I extend it a little bit further, we would get up to the x-axis or the x-intercept up here. But in the meantime, what we can do also is we can then say, okay, well, what we can estimate a few different values. So what if I estimated what happens, what's the value of y when x equals 6? So if I start at x equals 6 and I draw the line down until it meets the graph, and then I go across to the y-axis, we see that the estimate when x equals 6 for this graph, y equals -6. I can look also at when y equals 8, and I can come across to the graph. Where it hits the graph, then I move up to the x-axis in a perfectly vertical line, and see that the graph is x equals +3. Moving along to this next graph, we looked at this one the other day, and that graph has y-intercept of 30 and x-intercept of 15. Okay, so the y-intercept of 30. We looked at how to find x and y intercepts by, remember when the x-intercept, when you were looking for the x-intercept, we set y equal to 0, and so we ended up getting 2.8x equals 42. And then when we divided both sides by 2.8, we got x equals 15. And then when we were looking for the y-intercept, we did the same procedure. We set x equal to 0. And then, so that just left the equation as 1.4y equals 42. Therefore, y equals 30. And this is that point right there, 0, 30. Because x is 0 and y is 30. And then for the x-intercept, we know it's 15 and 0. And so I'll go down here, and I will plot that point here at 15 and 0. And once I have those 2 points, I can then join them with a line, and of course with the arrowhead going on the ends. And I'm going to have to estimate this again a little bit. So it's going to go through here like that, and then it's going to go, I didn't quite get it, but it's going to be going like this, more or less. And then I just have to make my adjustments to connect these lines a little bit to make sure that they're connected. Okay, so it's not perfect the way I've drawn it, but we get sort of the idea here of how we're graphing. And then from, again, we want to see some sort of solutions for the line. If we take a look at if we want to see what's the what value of y when x equals 10. Well, x equals 10, I start at x equals 10, and I go all the way up to the line, and then from there we go perfectly horizontal. And so my estimate for this is about 9.5. Okay, and that's an estimate because it's depending on how I've drawn the graph, how well I've drawn the graph. If I want to see, well, what's the value of y, if I want to estimate the value of y when x equals 5, well, then I start at x equals 5, and then I can go up to hit the line, and then straight across, and I see that's about 19.5. Okay, we can do the same thing in the other direction. We can see, well, what's the value of x when y equals, let's say, 14. Y equals 14 here. I come across to hits the line and then straight down vertically. And I'm off a little bit for my estimate, of course, and that's another reason why we're just calling these estimates. That would be 6, 7. So this would be 7, maybe 7.8. I know we can't really get super accurate. Had I drawn the line down a little bit straighter, or like where I hit the line perfectly, would have been about 7.8. Where I've drawn the line here, it looks like it's about 8 units exactly. But technically, this line should be over just a little bit here, more or less like that. So it might be about 7.8 or so. Okay. If I go back to the line that we drew a couple of days ago, here's the line that we graphed. Here's Desmos, and I look at the x or the y-intercept is 0.30. The x-intercept here is 15.0, and then again I can scroll along and see any ordered pair that will satisfy this equation. Any ordered pair, any x and y values that I could substitute into that equation of 2.8x plus 1.4y equals 42. Any one of these points along here, and here's one that's, I think it's supposed to be 10, 10. Any point along this line, if I substitute the x and y values into the equation, the left side will equal the right side. Here's another point here, 5 and 20. Okay, those two, the value, if I substitute the x value of 5 into the equation and the y value of 20 into the equation, the left side will equal 42, just like the right side equals 42. Okay, and then, so this is a way of finding different ordered pairs that will satisfy the equation. Okay, so this is just a quicker way to verify that. And I'll just go to one other graph that we've that we're going to look at. Sometimes we're given equations where there is no y, it's just written like this: 12 equals 6 plus 2/3 x. Well, it's basically just two sides to the same, to an equation. This is basically just y equals b plus mx. And so the right side is just the same as what we've done in the past. The y-intercept is 6, the slope is 2/3, and then we could draw the line, and then after that we can just find out, we can actually draw y equals 12, and I'll show you that in a second. So if I'm graphing this, I've got the y-intercept of 6, and then from here I'm going to go down, or sorry, up 2 units. So go up 1, 2, and then to the right 3, 1, 2, 3. I'll do that one more time, 1, 2, and then 1, 2, 3. So those, I just used the, just wanted to get a bit more separation between those. And then I'll draw the line through here and extend it. Try to draw it as accurate as I can. It kind of jumped on me there. Okay, and so that's the graph of the line 6 plus 2/3 x. Yeah, I'll just adjust this slightly here. And so that's the right side of this equation. Now if I look at the left side just says y equals 12. Well, y equals 12 is right here. Y equals 12 is also here and here. These are all the y values 12. And even though the x values are changing, there's different x coordinates for each of these points. I could write out the coordinates for each of these points, but I don't want to belabor this too much more than I am already. But all of these points have the y value of 12. In fact, if I were to draw plot points in between all these points, each of them will also have a y value of 12. And then if I went in between those, they would also have. So basically, here is here's the equation, y equals 12. And it's just a horizontal line that goes through y equals 12. So the left side of that equation, where it says 12 equals, is just the line y equals 12. And then from there, you just look at the point of intersection, which is right here, where the two lines intersect. And then we just follow the line, we just go down vertically from there, and we see that the the solution to that then would be, if I go down here, from y equals 12, we go straight down, we see that that's x equals 9. So if I were to substitute x equals 9 into this equation, algebraically, I could calculate that the right side would end up being 12. And I'll just do that very quickly here. If I look at the right side, 6 plus 2 over 3, we know that right side, the x value here is 9. This is the ordered pair 9, 12. So I can say 6 plus, and then we know that there's an imaginary 1 underneath the 9 here. So if I can multiply those fractions, so I get 18 over 3, because you just multiply straight across, you get 6. 18 divided by 3 is 6, and 6 plus 6 is 12. And we know the left side equals 12. Therefore, we say left side equals right side. We have to make sure we separate these so we don't state that they're equal all the way down until we actually prove that they are. Now we put it together, left side equals right side, and therefore it is true that x equals 9. Okay, so that's how we do this, this type of equation. Now, if I go to the next thing, here's the same line again, 6 plus 2/3 x, and -4 is the y value we're going to be looking at. And I'm actually going to just do this on Desmos just for the sake of brevity. And we're going to go over here, and 6 plus 2/3 x is this graph here. And here's 0, 6 is the y-intercept as before. And we want to see where what the intercept is when y equals 12. So, or sorry, y equals -4. So if I'm going to go to -4 here and plot this line, we see that the y-intercept, or sorry, the point of intersection is -15, -4. So the actual solution to this, if from this equation, -4 equals 6 plus 2/3 x, the x value that makes this true is -15. So if I go back to this, we see that the x value for this is -15, okay, from what we saw in the last example. And if I go one more time, now I'm going to change the order of this. So the equation is 6 plus 2/3 x, y equals 6 plus 2/3 x. And all the time we've been looking at this value over here to the left. If the value is on the right, it's not a big deal. It's just the same thing. Here's 6 plus 2/3 x again, and that equals 2. So the graph's going to look exactly the same as it did from before. This has a y value of 6 and the slope of 2/3. Now we want to know what the x value is when y equals 2. So I'll go back to Desmos to help us out here. And so if I look when x equals 2, I just try to get this right on. There we go. When y equals 2, the point of intersection intersects when y equals -6. Okay, and so that's basically how to graph these, find the solutions, estimate solutions of linear equations when we're given a y value. We just have to draw the horizontal line at that y value, see where the point of intersection is, and then that gives us the x value that corresponds to that solution. So thanks for watching, and see you in the next video.